Hi, Luis. My name is Ross. I hope I can help with this problem you posted. It's a pretty tricky one, but it all starts here with this very first piece, the partial derivative. Super important to recognize that we're being asked to take the derivative with respect to x, that's why x is on the bottom, and they want you to find z. They want you to find dz dx, the partial derivative of z with respect to x. And that means a few really important things. First of all, the easiest part is since y is not involved here, we could also write this as just dz dx. Y is going to act like a constant. So think about what happens when you take the derivative of a constant. The derivative of 6, for example, is just 0 automatically. That same thing will happen to y now. The derivative of y, because it's not involved in this fraction, the derivative of y will just be 0, which is going to make some things a little easier. X and z will still act like variables. Their derivatives are going to act a little bit differently, though. So let's start with this very first piece. 2xy, if we take the derivative of that, remember we're taking that with respect to x. You might think that we need the product rule because there's two variables, but remember that y is going to act like a constant. So instead of 2 times x times y, think about this as just a constant times x. And when we take the derivative like that, the only thing left is the constant, which in this case would be 2y. Both of those are constants. The derivative of x is 1, and we're left with 2y. The next piece, z squared times cosine of x, is going to require the product rule because you have two terms, both variables being multiplied together. So we have the z squared as our first term and the cosine of x as the second. These two derivatives are going to act a little bit differently, and we'll talk about why. There's a few different ways you can write the product rule. I'm going to go with the way I prefer. I like to do the first term, so z squared, times the derivative of the second term. The derivative of cosine of x is negative sine of x. Please excuse the crappy handwriting. So that's the first half of the product rule. And then I like to do the second term, so plus the second term is just cosine of x times the derivative of the first term. And this is where it gets tricky. The derivative of z squared, the beginning is really easy. Derivative of z squared is just 2z. But now we have to reconsider what we were asked for. Since we're trying to take the partial derivative and find the with respect to x and find the partial derivative of z, anytime we take the derivative of a z variable, like we just did here, we have to multiply the result by dz dx. And this is a key and a trick to all of these types of problems. Whatever that variable on top is, the z in this case, when you take a derivative of one of those, it's gotta be accompanied by the dz dx in this case. So all of that was just our derivative of the middle piece. Now we're going to do the derivative of this last term. You may again think, here comes the product rule, but don't forget that the y is acting like a constant. So the derivative of a constant times z is just going to be that constant. So we're just going to have plus y here. And since we didn't take the derivative, and since we took the derivative of the z, right? Just like a minute ago, we have to add on dz dx. One more time. We took the derivative of zy. Z is the variable we differentiated. So the derivative is technically 1, but we have to multiply on the dz dx since we're doing that partial differentiation. That only applies to z in this problem because it's on top, not to x and y. And then I think the easiest part of this problem is the end. The derivative of 8 is 0. Now we need to solve for dz dx. That pops up a couple times here. But I would suggest that the easiest thing you can do here is actually go back up here to the values you were given. You know that x is 0, y is 1, and z is -1. So at this point, it will be easiest to go ahead and plug those in. So that's what I'm going to do. So we're going to have 2 times positive 1, that's our y, plus -1 squared, z is -1, times, and then negative sine of 0. Sine of 0 is just 0. Plus the cosine of 0, which is 1, times 2 times -1, plugging in that z, times dz dx. We don't know what that is, and in fact, that's what we're trying to solve for. That's our variable here. Then plus 1, another dz dx, equals 0. So now that makes it a lot easier because we've gotten rid of almost all of our variables. The only thing left is the dz dx's. So let's clean this up a little bit and see what we have. 2 times 1 is 2. -1 squared, be careful, that's +1, but it's times 0, so that whole thing is 0 anyway. Then we have 1 times 2 times -1, so that's going to be -2 dz dx. And then at the end, plus 1 dz dx. So this is getting quite a bit cleaner, quite a bit simpler. Consider here now that we have -2, it's just like any other variable, -2 dz dx plus 1 dz dx would be -1 of those things, -1 dz dx. And now we're just solving basic algebra. We can do this a couple different ways. I'm going to subtract 2 on both sides. That's going to leave me with -1 dz dx equals -2. And if you divide or multiply by -1 on both sides, you'll find that dz dx is equal to +2. So I hope that helped. I hope that made sense. Feel free to ask a question and post a comment. If not, and have a great rest of your day.